All right. How to translate using your compass and a straight edge. You'll have a figure to translate, and you'll have a vector. The vector is the most important thing. Let's just quickly review from yesterday what a vector shows us. Two things. It's going to show us the direction we're going to slide. So this triangle should be somewhere over here. It shouldn't be down here over the line, over here, over here, over here, anywhere. It's telling me it's this. We're going to slide this direction. So FDE should end up somewhere in this vicinity. So the vector shows us what direction and what distance we're going to slide. So however long the vector is, that's how far F, D, and E are going to move in this direction. So we all good on the two things the vector is going to do for me. All right, so let's start out by moving point F, all right, and finding F prime. First thing I need to do, I got to measure the vector. If I'm going to slide it the length of this vector B, I'm going to need to measure it with my compass. Go to F now, the point we are sliding. Put your compass point on F. And you want to make not a huge arc, but just an arc out in front. Now, somewhere on that arc is going to go F prime. Somewhere. Because we've matched the distance now. Somewhere. I just got to make sure it's in the correct direction now. And here's the second and final part. Go to the beginning of the vector. Put your compass point on the beginning of the vector. And the pencil point on F. No marks needed. Any idea what I'm going to do next to make it intersect that first arc, where I'm going to go next? Connor, thoughts? I'm going to go to the end of the vector now. Yep, to the tip of the vector. And I'm going to make it intersect. And there you have it, F prime. Now, I really think, especially in an honors level class, if you see why this works, that maybe it'll become easier as you do these, all right? So I want to show you why it works, even if you don't care. I'm still going to show you in an honors level class. Why does this work? Well, tell me again, what are the two purposes of a vector? Direction and distance. So how do I know the direction and just by what I did on those steps, how do I know the direction and the distance is the same as this vector from F to F prime? Here's why. What's the first thing we did? We measured the vector and then brought it up here. Everyone agrees? So don't do this on your paper because I'm going to erase this on mine in a second, but take a look. So does everybody agree F to F prime, those distances are the same, right? So this dotted line I just drew in and the vector are the same length. Then what did I do? I went from the end of the vector, or the beginning of the vector to where? So this is the same distance as that right there. Everyone agree? So you just showed me, hold on, you have no idea what's going on. You just showed me those two are the same distance. Those two are the same. What did I just create up here? Parallelogram. Not only are opposite sides congruent, but they're also parallel, so it has to go in the same direction. So basically, I'm just building a parallelogram on this construction every time. Okay? Distances are the same, and how do I know it's going in the same direction? Well, they're parallel, so it has to go in the same. All right? All right, so I'm going to get rid of those right now, and then we're going to do the same thing for point E and D. So I'm going to go to point E next. Just let me get rid of those dotted lines. So everyone go back, measure your vector. Bless you. Everyone go back, measure your vector. Just let me get rid of these. Put your compass point on E now. And make another arc. And then now beginning of the vector to E. I know this is, hopefully you can do this. I know it's a small distance, but go to the end of the vector, right to the tip, and make those two intersect. Build your parallelogram. There's E prime. And let's do it for D. Go back. Measure the vector. And I don't know if some of the wheels are turning. Is there maybe a way we can discuss at the end of this? Maybe I can eliminate some of the steps because you're doing the same step over and over again. We'll talk about it. All right, so measure the vector. Go to D. Draw on your arc again. Beginning to D. If you forget these steps tonight, they're all up on Aspen. I put the YouTube page on, the YouTube video on there for translations. And there's D prime. Connect it. If you want to color it in, shade it in, whatever floats your boat. Here we go. And it's an easy check. Should be going in the same direction that vector is. It should never be flipped over the vector. All right, it should never be flipped. Should always be move that direction of the vector's going. All good? Hey, if you want to, you can do this if you feel comfortable, but aren't we doing the same step every time we go to a different point? What do we always have to do at the beginning? Measure the vector. So if you want to eliminate some steps, and you can handle it, measure the vector at the beginning, and then go to each of the points and just make your first arc right now. The only problem you may have is make sure you know what arc belonged to what point. That's up to you if you can handle it. It just eliminates remeasuring the vector every time you go to a different point. All right, so I'm going to let you guys practice. I'm going to walk around, see how you're doing. You have 2 to do. And then once people are done with those 2, we'll go to the final thing we have to do, and then we'll call it a day. All right, here we go. No issues. We didn't have any issues with this one. A lot of people, no issues with that one. And then we come to here now. Okay, we did this just quickly reviewing yesterday. I saw a lot of you guys already trying this out. Good. So I'm going to take square RSTU. I'm going to move it 2 units down and 3 units to the left. So if you haven't done that already, that's the first job. Make sure you call it R prime, S prime, T prime, U prime when you do that. So go 2 units down, 3 units to the left. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2.
Does anyone else still have to do this? She just doesn't. She just holds like this. She just doesn't touch the handlebars at all. Yeah, I tried to hold. No, that's not that. Why do you? Because like sometimes I'll be getting directions and then I'll be like.
Good story. Nobody cares. All right, moving on. Moving on. Now that you have it moved, draw the vector that defines this. So you need a vector that shows that you went 3 left, 2 down. Yesterday we talked, the easiest way to draw that vector is from what? Pre-image to image. So if you want, pick a pre-image to an image, draw that vector in. Or if you want to go hardcore, do it off the graph. Make a point, and then just make sure you go 1, 2, 3 to the left, 2 down. and the end of the vector is right there. If you want to go hardcore, somewhere on the graph though needs to be that vector that goes 3 left, 2 down. All right. All right, and then you got one more here, but now we're going 2 right, 1 up. 1, 2. No compass needed when you're drawing in your own vector. Just make sure, hold on, because I got some instructions for the homework. Just make sure when you draw your vector, you start at the pre-image and end at the image point. All right, one thing I need to tell you about the homework, because I'm sure you might have a question with it. If you go to page 17, on page 17, the directions are to draw the vector, but you got to know what the pre-image and the image are to do that, or it's going to be backwards. The pre-image is the dashed, the image is the solid. Okay, pre-image is the dashed, image the solid. All right, so when you draw your vector. All right, you got the rest of the time to work and probably finish.